Quadratic functions and applications. What's a quadratic function? A quadratic function is a function that may be written as f of x equals ax squared plus bx plus c, where a, b, and c are real numbers with the property that this guy a is not 0. We've encountered a quadratic formula before. For instance, if you consider the situation where a is equal to 1 and b and c to be both 0, what would happen to f of x? What would happen to this function? So if b and c are both 0, this whole thing here vanishes, right? This becomes 0. And if a is 1, the expression becomes simply x squared, right? So then the function becomes x squared. And we've seen this function before. This function, recall the graph of this function. This function has the parabola as its graph, right? So something like this. Correct? So this is the graph of y equals x squared. We learned this in an earlier section. And the vertex here, I mean, certainly this graph crosses the origin, right? So it goes through the origin. And that vertex is the origin. And the line x equals 0, which is the y-axis, is an axis of symmetry. Okay? So as it turns out, any quadratic function has a parabola as its graph, and in fact it's going to be obtained by a sequence of transformations that we learned from a previous section. That's going to be done on the parent function y equals x squared. So any quadratic function is going to have a parabola as its graph by doing or by performing a sequence of transformations on the parent function y equals x squared, as the next property is going to illustrate here. So let's read this property. A quadratic function f of x, which is ax squared plus bx plus c, can be expressed in vertex form or standard form, which means something like this, by simply completing the square between those two terms. If you complete the square between those two terms, we're gonna talk about it just shortly, but if we complete the square between those two terms, then you're gonna be able to transition this writing into this writing. And now let me convince you that by performing a series of transformations on this function y equals x squared, you're gonna obtain something like this. Look, this h here is gonna, x minus h squared. So what are you doing here? You're doing the transformation horizontal shift by the amount h to the right, correct? If h is positive, and to the left if h is negative. And then the entity a, if a is negative or a is positive, is gonna allow us to reflect in the x-axis and do some vertical stretching or some vertical shrinking, right? And that k is a vertical shift. If k is positive, you're vertical upward, you're shifting upward, and if k is negative, you're shifting downward. Okay? So if you ignore a for a second, this amounts to saying that you are shifting the parent function x squared horizontally in the amount h and vertically in the amount k, correct? So the vertex is gonna become, the vertex of this function f of x is gonna become the point whose coordinates are h comma k, right? H comma k, correct? So I'm trying to convince you that this is actually the vertex of such a function, because we started from 0 comma 0. This is 0 comma 0. So if you go h units horizontally and k units vertically, so you are shifting this to be h comma k, right? Okay. So the vertex becomes this. And depending on a, depending on this number a, for example, if a is positive, what are you doing to the parent function? You are performing vertical shrink or vertical stretching on the graph of the parent function. But the idea is this function, if a is positive, it's gonna remain opening up like the parent function. Okay, so it's gonna open up if the coefficient a is positive, and if a is negative, then you are reflecting, right? You are reflecting in the x-axis, and then you're performing the vertical shift or the vertical shrink or vertical stretch. So if a is negative, the function is gonna open downward, right? So this is the next comment here in this property. So the parabola opens upward if a is positive, like the pink trajectory here, or downward if a is negative, so something like this. Okay, the vertex is gonna remain h comma k all the time. The vertex is h comma k, no matter whether it opens upward or downward, correct? Because this is the amount of vertical and horizontal and vertical shifts that we're doing to the parent function respectively. Okay, all right, and now if it opens upward, this vertex at this vertex here, so at x equals h, the function is gonna reach a lowest value, right? It's gonna reach its lowest value, so it's gonna be called the minimum value. And if the function opens downward, then at x equals h, when x is equal to h, then the function is gonna reach its highest value, which is the maximum value, correct? So you're gonna get this. Okay, so f of h, which is k, is gonna be in the case when a is positive, so like this, it's gonna be the minimum value, the lowest value. And if a is positive, if a is negative, so the green trend, then at this point x equals h, we're gonna have a largest value, which is the maximum value. So f of h is gonna be the largest value. And what's f of h? It's k, right? So this guy is f of h, right? Because it's part of the graph. And if you, you can think about it also algebraically. If you replace x by h, right, this whole thing is 0 because h minus h is 0. So this is 0 and f of h becomes simply k, correct? All right, so we're still talking about the same thing here. All right, and the last one is the axis of symmetry is the vertical line that passes through the vertex, namely x equals h, right? So the vertical line x equals h is the axis of symmetry. Again, because we shifted horizontally the parent function in the amount h, correct? So that vertical axis, which was x equals 0, is gonna shift now the amount h, and hence it's gonna become at the location at x equals h. So the new line x equals h is gonna be the axis of symmetry of this function. Okay. All right, so now let's go to the book and do a few examples. This is on page 248, so this is section 2.1, and let's go to page 249 and do problem, how about problem 8 here? So we have a bunch of questions. Let's actually take a picture of the questions, and we are talking about problem 8, so let me copy it for you. So these are the questions. Okay, and this is on page 249. Actually, I'm gonna write it here. So page 249. All right, so this is number 8 now. We have g of x equals minus the quantity x plus 2 to power 2 plus 4. And what the questions, or we have 8 questions. So the first one is determine, so this is part A, determine whether the graph of the parabola opens upward or downward. So based on the discussion that we just had, what's going to determine whether the parabola opens upward or downward is the A, right? Is the A. If A is positive, the parabola is going to go downward, upward, and if A is negative, then the parabola is going to go downward. And who's A? That's the A. So it's the guy sitting here, correct? So who's our A here in our context? It's -1. So since A is -1, since A is -1, which is negative, by the property above, we know that the parabola is gonna opens downward, right? So the parabola opens downward, correct? So part B, identify the vertex. Identify the vertex. So let's revisit the property, the theoretical aspect. What is it? Whenever you write it in vertex form, this is called vertex form, right? So whenever you write it in vertex form, then you gave yourself the vertex, and the vertex is H, which is this guy as long as there's a minus in front, and K, right, the second coordinate K, as long as there's a plus here, correct? Okay, so a direct comparison is gonna tell me that the H is -2, correct? Let me make the case again. Let me copy this so you see it. You can actually compare the two directly. So let's take it below. All right. So look, if you compare the two, if you compare this guy with this guy, the H is this as long as there's a minus here. Well, I have it too, but there's a plus, right? So who should be the H? Well, to set the stage for H to be visible, let's rewrite this as x minus the -2, correct? Do you agree with this? Squared plus the 4, correct? So now it's visible that with this minus, and this minus are the same, then this guy is the H, correct? So who's the H then? It's the -2. So H is -2. H is equal -2. And how about the K? K is this constant part as long as there's a plus here. So I have the plus, so K must be just 4. So K is 4. So the vertex is simply H comma K, which is -2 comma 4. Agree with that? So we get this. Okay. All right. Part C. Determine the X-Intercepts. So determine the X-Intercepts. Well, to determine the X-Intercepts, remember how we find this? These are the points where the value of the function vanishes, right? So we are looking for real numbers x for which g of x is 0, right? Remember, those guys are solutions of this equation, correct? So this is where those are the x coordinates of the points on the graph of the function whose second coordinate is 0. So g of those guys should be 0. Okay? All right. And what does g of x equals 0 mean? G of x equals 0 means in this context that this guy is 0, right? Because this is what g of x is. Okay, so I'm gonna copy. So this means minus the x plus 2 squared plus 4 should be 0, right? Okay, so let's keep solving it algebraically. And this is equivalent to saying if you subtract by 4, you get this. Correct? And then if you multiply both sides by -1, then the minus here and the minus here are going to cancel each other. Correct? So let me do it again. I move, you can move this guy. You can move this guy to the other side, correct? And if you move this guy to the other side, it's going to become a plus that guy squared, and it's going to equal to the 4. Okay? Alternatively, you can take the 4 to the other side, so it becomes -4, like I did here, and then you can multiply both sides by -1. That minus and this minus are going to cancel each other, so you get so you simply get this, right? Okay, and now something squared, let me appeal to the property that I'm going to use. Let me write it. So remember, when we have something squared equals a non-negative entity, if b is non-negative, that's the same thing as a is plus or minus the square root of b, right? So we discussed this at the beginning of the course. Okay, so who's a, who's b? A is the guy that I'm squaring, so that's the guy A. That's the guy A. And who's b? That's the guy b, right? And certainly this guy is non-negative. 4 is bigger than or equal to 0. Okay? As such, what do I obtain? I obtain that A is plus or minus square root of b. So A, which is x plus 2, is equal to either minus square root of b or plus square root of b, right? So plus square root of 4 in this case. Okay? And what does this mean? What's square root of 4? What's square root of 4? It's 2. So x plus 2 is equal to -2, or x plus 2 is equal to 2. One more time, why this is the case? Because this guy is 2. Right? Square root of 4 is 2. Okay. Very good. So we get to this point. Remember what I'm after? I'm after the x. I'm after the x for which g of x is 0. So g of x is 0. I'm unraveling what it means for x, and I'm down to this point. I'm almost there. The only thing missing is I need to subtract by 2 both sides. So I get x equals -4, or, right, if you subtract by 2. And here I'm subtracting by 2, I get x equals 0. Correct? So what can you then conclude? When x is -4, the value of the function is 0. So therefore, -4 comma 0 is an x-intercept. And when x is 0, g of 0 is also 0, because x equals 0 verifies the equation g of x equals 0. So g of 0 is also 0. So 0 comma 0 is another x-intercept. So these are the x-intercepts. Correct? Okay. So these are the x-intercepts of the function g. Okay, so we've done C. D, determine the y-intercept. The y-intercept. We know how to handle y-intercept too, right? Well, the y-intercept is simply where the function crosses the y-axis, which means I'm going to look for g of 0, right? So where the function crosses the y-axis, that point, if the function is g, is going to have first coordinate 0 for sure, because it belongs to the y-axis, and the second coordinate is going to be g of 0. Correct? So what's that? What's g of 0? We've just talked about it. It's 0. Right? If you want to double check, plug in 0 in the function g. Right? G of 0. What do you obtain? G of 0, you're going to get, this is going to be 0, so 0 plus 2 is 2, 2 squared is 4, -4 plus 4 is 0, right? So then, 0, comma 0 is, it was an X-intercept, and it's also a Y-intercept, as the Y-intercept. Correct? All right. So now down to E. Sketch the function. Sketch the function. So let's collect the information that we have. The vertex is at -2, comma 4. It opens downward, right? So the vertex is there at -2, comma 4, and it crosses the x-axis at those points, -4, comma 0 and 0, comma 0, and the y-axis, it crosses it at 0, comma 0. All right, so let's do that. Let's say that this is the xy intercept. Sorry, xy plane. Okay. And the vertex, where was the vertex again? It was at -2, comma 0, -2, comma 4, right? So -2, let's say here, comma 4. So the vertex is right there. That's the vertex. -2, comma 4, right? So let me take you back to this. -2, comma 4 was the vertex. It opens downward, and it crosses the x-axis at the points -4, comma 0. Where is -4, comma 0? If this is -2, -4 is going to be somewhere here, right? So that's the point -4, comma 0. And it's going to cross the x-axis at 0, 0 and the y-axis, because they're both 0 in this case. So it's going to cross it at the origin. So that's the point 0, comma 0. Correct? So the function technically is going to be a parabola that opens downward, and it's going to go through these points. So something like this. Again, with a grain of salt, it's not very accurate, but something like this, right? It should look like a parabola. It doesn't. But it should look like a parabola. Okay, so something like this. Okay. All right, so this is the function g of x then. That's the function g of x. And the function keeps going down this way, right? It's a parabola, so it never picks up again. So it blows down as x increases and as x decreases towards infinity, negative infinity, right? Okay. So that's part E. Part F, determine the axis of symmetry. Determine the axis of symmetry. Remember in the property before, the axis of symmetry is the vertical line that goes through the vertex, which is x equals h. Okay? So x equals h is, so in this case it would be something like this. And in this case it would be something like this, right? So x equals h is the axis of symmetry. So who's h in my context? We found h to be -2, correct? So x equals -2 then is the line of symmetry. So that's part F. It's x equals -2. It's this line, right? It's right there. Again, the picture is not very correct, so it's not accurate, but you got the concept. So that's x equals -2, which is the axis of symmetry. Okay, so that's F. Part G, determine the minimum or maximum value of the function. Let's go back to the property that we got. If the function has positive a, in our case we didn't have positive, right? We got the negative. So if a is negative, then the function is going to have a maximum value at h when x is h, and that maximum value is going to be f of h, which is k. Correct? So in our context, we're going to have a maximum value because a is negative. We're going to have a maximum value, and it's going to occur at h, which is equals -2, and the value is going to be f of h, which is 4. Correct? That point, I'm talking about the vertex technically, the height of the vertex. That's the largest value that the function takes, correct? So g, the function g of x has a maximum at x equals -2. That's the h guy. And that value is, and the maximum value is f of -2, which is equal to, so f of h is gonna be the k, and the k in our context is 4, right? I mean, it's explained through the picture, the graph. So at -2, the function attains its maximum, its largest value, which is this point, and which is of height 4. So the maximum value is 4, right? Okay, so that's part G. And lastly, part H, write the domain and write the range in interval notation. So the domain, remember this quadratic functions are shifts, or not shifts, transformations of the parent function y equals x squared. So the domain is going to be the same. The domain is going to be the same, which is all real numbers. Correct? I mean, this is also explained by through the picture, the graph. Since this function keeps going down forever and down forever this way, if you try to flatten the function along the x-axis, you're going to see all of the x-axis. So the domain of G, so the domain of G is all real numbers. Now, how about the range? How about the range? The range is all the possible outputs that can be obtained through the function. Correct? So since this function blows down, all these negative values are gonna be possible outputs. Correct? All these negative values are gonna be possible outputs. And still, all the way to here, 0, 0 is part of the output, right? Part of the outputs. If you plug in, sorry, 0 is part of the output, because if you plug in 0, you get the output 0. And so on and so forth, and until we get to the largest value, which was 4. We talked about it. The largest value was 4. So 4 is the largest, but anything below 4, up to 4, is also attained. Okay? But nothing beyond 4. So what's the range? It's minus infinity all the way to 4. So the range of G is all real numbers that are at most 4. Okay? Let's do another problem like this. How about problem 10 on the same page? So now we have k of x to be this function. Still have the same questions, right? So let's do number 10. So now number 10, same questions. Now the function is gonna be k of x is equal to 2 times x minus 3 squared minus 2. Okay? All right. So for part A, the question in part A, what's the question? The question is, determine whether the graph of the parabola opens upward or downward. And we talked about that. That depends on the coefficient, on this guy, little a, right? Labeled in the formula. So if that guy is positive, then the function is going to open upward. And if that guy is negative, then the function is going to open downward, right? So in this context, a is positive, so the function is going to open upward, correct? So since a is equal to 2, which is positive, by the property above, the function k, or the parabola, which is the graph of k, opens upward. Okay. Part B. What's part B? Well, part B is identify the vertex. Identify the vertex. Recall how we find the vertex based on the property? Well, the vertex is simply this guy h. It's gonna have two coordinates. This guy h as the first coordinate and this guy k as the first coordinate, as the second coordinate. As long as h is accompanied by a minus in front and k with a plus. Okay, so I'm gonna do the same as I did earlier. I'm gonna take this so we can compare it directly. All right, so let's compare the two. Who's h and who's k? I'm talking about this k, not the function's name k. Okay, it's an unfortunate name for the function, but I mean this k, the y-coordinate of the vertex. So clearly h is 3, right? Because the minus is there. So clearly h is 3. Let's write this down. So h is 3. And how about the k, the y-coordinate of the vertex? Well, I should have a plus, don't forget. I should have a plus. To turn this into a plus, I can rewrite it as plus the negative 2, right? And now it's clear that the negative 2 is going to be the k. Agree with this? Okay. So who's k then? K is, let me change it to purple. So k is negative 2. Okay. And as such, the vertex is, so the vertex has the two coordinates 3, negative 2. Okay. So the function is, the parabola is opening upward. It's gonna open upward, and it's gonna have 3, negative 2 as its vertex. So I'm collecting the information. Part C. Part C was determine the X-intercept. Determine the X-intercept or X-intercepts. Well, this is where the function is gonna cross the x-axis, which means where the function vanishes. So we're gonna try to find all the x so that k of x is equal to 0, correct? Okay, and that's equivalent in my context to, let's rewrite it as it used to so we don't confuse ourselves. So that's equivalent to having 2 times x minus 3 squared minus 2, right, equal to 0. And that's equivalent to saying that 2 times x minus 3 squared is equal to 2, correct? Which means, if you simplify by 2, this means that x minus 3 squared should be 1, right? So this should be 1 then, if you divide by 2. I just divide both sides by 2. And this means, again, according to the same property, this property that I talked about earlier, right? If a squared is equal to an entity which is non-negative, then a must be plus or minus the square root of b. So I'm gonna employ it again. Let's actually rewrite it. So if b is non-negative and a squared is equal to b, that's equivalent to saying that a is plus or minus square root of b, right? Okay, so who's the b, who's the a? The a is the guy that's squared, so this guy is the a. And who's the b? It's the guy on the other side, that's the b. So according to this property, I'm gonna have a, which is x minus 3, is gonna be plus or minus the square root of b, and square root of 1 is 1, right? So either negative 1 or, so technically I should have square root of 1, but square root of 1 is 1, or x minus 3 is gonna be plus the square root of b, which is plus 1. And what does it mean for x? So if you add 3 to both sides, you get that x is 2, just add 3, or x is gonna be 4, right? If you add 3 to both sides. So 2 comma 0 and 4 comma 0 are the x-intercepts. So thus the x-intercepts are 2 comma 0 and 4 comma 0. So the function is going to cross the axis a couple of times. So if this is the x-axis, this point here is the 2 comma 0, and this point here is the 4 comma 0. These are the x-intercept, right? I'm trying to collect information along the way. So 2 comma 0 is this guy, is this point, and this point is going to be 4 comma 0. This is the x-axis, right? So the function, the parabola, is going to cross these, is going to cross the x-axis at these points. This is what our analysis tells us, right? All right, I'm going to throw a hypothetical situation. What if instead, let's change the recipe of k of x. What if instead I had a plus here? Okay, I'm just throwing a possible situation. I'm changing the problem for a second. So if I change this to plus instead of minus, this guy becomes minus, right? This guy becomes minus because you're subtracting by 2. And then if you divide by the 2, that's going to become a negative 1. This is no longer applicable because the b becomes negative, right? So this is no longer applicable, and as such we cannot proceed as we used to. So instead we have to, we are on our own. But look, in this situation, if you have a minus here, x minus 3 squared is equal to negative 1. Well, whenever you square something, there's no way you're gonna get a negative number, right? So one more time. Since this is not applicable, I'm not gonna proceed as before. So I am on my own, and I have to deal with it independently of this property. The good thing is, squaring x minus 3 certainly is gonna yield a non-negative entity. So this guy is certainly greater than or equal to 0, because you're squaring a number, right? A real number. If you square a real number, the least you get is 0. So there's no way it's gonna reach negative 1. Correct? So there is no x that's gonna make this job then. And as such, we're not gonna have x-intercepts. Right? And what does it mean? What does it mean geometrically? Geometrically, this means that the x-axis, if it opens upward, the x-axis is below the vertex. Make sense? Because if it were to be at the vertex, this means there is one x-intercept, and if it's somewhere above the vertex, then it's gonna cross a couple of times, like we did in our current context, right? In problem 10. But the only way that they're not gonna cross is when the x-axis is below the vertex. Okay? So if the function k of x had this recipe with a plus, the function would have still opened up. The vertex is gonna remain the same. It's gonna be 3 comma plus 2. Obviously, we have to switch the k, but the vertex is gonna be somewhere here, and the x-axis is gonna be below the vertex. As such, there's not gonna be any x-intercept. Okay, just for you to know. Okay, so let me erase all these back. Okay, so in our context we have x-intercepts, and there are 2. Okay, part D. So part D. So determine the y-intercept. The y-intercept is where the function crosses the y-axis, which means when the x-coordinate is 0, right? So I want to evaluate the function at 0. Okay, so what's k of x again? That's k of x. Well, k of 0 is going to be, instead of x, I'm going to have 0, right? So I'm going to have 0 minus 3, which is minus, you know what, let me just do it below. Let me copy this so you get to see the entire computation. So k of x is that. So k of 0 is gonna be 2 times, instead of x I'm gonna have 0 because the input now is 0, minus 3 squared minus the 2, right? Okay, I don't need this anymore. So I placed x by 0, and what is that? So this piece is -3. Just the guy under, before or inside the parentheses, before I square it. Once you square it, you get -3 squared. So you're squaring -3. And what's -3 times itself? Is 9, right? So you get 2 times 9. So you get 2 times 9 minus 2. And what's 2 times 9? Is 18. And 18 minus 2 is 16. Correct? So k of 0 is 16. Therefore, 0, 16 is the y-intercept. Okay, of this function k. All right. Part E, sketch the function. Sketch the function. We've sketched a good chunk of the function, actually. Remember, it was here. Let's do it. Let's copy it. Actually, let's take it below. So that's part E. That's part E. The only thing is where it crosses the x-axis, the y-axis. If this is the y-axis, I know now it's gonna cross it at 0, 16, right? So I know now that the function is gonna. Let me erase a piece of it so it becomes better. So the function now is gonna be. I know it's gonna cross it at 16, so this number is gonna, this point here, this height is gonna be 16, so that's 0, 16, and the function is gonna open up like this, right? Again, with a grain of salt, it's not very accurate, obviously, but oops, but it's not that bad. Okay. All right, so this would be the graph. Now, part F. Determine the axis of symmetry. When the axis of symmetry, based on the property that we just read above, is x equals h, right? Is x equals h. This guy, x equals h. And whose h here is 3, correct? Remember, h was 3 here. So h is 3. So part F. Let's write it here. So the axis of symmetry, is the line, is the vertical line, x equals 3. X equals h in general, right? Okay. Part G is determine the minimum or maximum value of the function. Since this function opens upward, then there's no largest element, there's no largest value because the function blows up. But there is certainly a lowest value, and that lowest value occurs when x is at 3, which is the h, and the image of 3 under the function, which is k of 3, which is -2, is going to be the lowest value that the function reaches. Correct? So the function attains its minimum at x equals 3, and that value, and that minimum value is k of 3, which is -2. It's the k, it's the y coordinate of the vertex, right? It's -2. That's the lowest value it takes. Okay? And lastly, write the domain and range and interval notation. So write the domain and range and interval notation. So that's part H. the domain of the function, so the domain of the function k is what? Well, the function k is a quadratic function, so it's defined everywhere, like the parent function x squared. So is all real numbers. I'm not writing it in interval notation, but you know that this is minus infinity plus infinity, right? So this is minus infinity plus infinity. Again, feel free to interpret the domain in any way you want. Doesn't have to be only in interval notation. And the range of this function k is, so the range is the collection of all the possible outputs, right? Well, the outputs here are anything, if you try to project all the points on the graph onto the y-axis, meaning you're gonna only pay attention to the y-coordinates of the points on the graph, you're gonna see all those points from -3 onward, right? From minus 2 onward, correct? Because -2 was the lowest, so that's the lowest it's gonna reach. So any number from -2 onward is reachable via the function as an output. Okay. Before we actually proceed, let me take you back to the property, and when we read it, it says a quadratic function f of x equals ax squared plus bx plus c. So any quadratic function written in this form can be expressed in vertex form, and this is by completing the square. Okay, and I promise you to show you how we transition from this writing to the vertex form by completing the square. So in order to transition, I'm gonna digress for a second to remind you on how to complete the square. So let's suppose, actually, how about we recall the following? How about we recall the following? What's the square of a sum? So what's the square of a plus b? Well, if you FOIL this out, a plus b squared means a plus b times itself, right? So you FOIL it, you're gonna get a squared plus twice ab plus b squared, correct? This is what we get. And if you have a minus here, if this guy is a minus, then the minus, this guy is gonna change into a minus. Okay, all right, let's focus just, let's say, on the purple for a second, and let's say that I have the following situation: x squared plus some number, let's say n, x. Okay, let's say I have this expression, and I would like to complete it in such a way so that it becomes a perfect square. So I would like to pay a certain price to have a component of this expression that looks like a perfect square, like this. This is a perfect square, right? It's a square of something. Okay, all right. If you just make direct comparison, you're gonna realize, if you make direct comparison between this guy and this guy, you're gonna realize that I can take I can take a in the formula to be x, correct? So I can take this guy to be x. Okay, and the question becomes, if this guy is x, what's b? Well, how about we compare this guy here with this guy and try to infer what b is? So don't forget, I just took a to be x, right? So I took a to be x. So this guy is technically now x. And as such, if you compare this expression with this expression, what do you infer? What do you infer about n? It should be, so n should be, let me change the color. So n should be twice b, right? This guy. Why? Because this x is already here, and I'm comparing this term with this term. So the only thing for them to be the same, I need 2b to match n. correct? So if I want 2b to match n, I'm asking this to happen, right? And as such, what's b? So that is to say b is equal to n over 2, right? So I can take b then to be n over 2. Okay? All right. So with this little analysis here, what can we say? What can we say? What's then? So then x, I'm taking a to be x, plus b, which is n over 2. If you square this part, what do you obtain? What do we obtain? Well, I know how to square a plus b, right? Let me erase all these. I know how to square a sum. This is a sum. I'm squaring a sum. So this is equal to, so a is x, b is n over 2. So a squared becomes x squared plus twice ab, so twice x, and b is n over 2 in my context, correct? This part is this part, and this part is this part, when a is x and b is n over 2. Okay? So, and then the last part is b squared. B squared, if b is n over 2, b squared becomes the square of n over 2. Right? And what do you realize here? You realize that this guy is, I mean, you can simplify by 2, right? You can simplify by 2. And what do you obtain? Let's rewrite the whole thing without the 2's now, because I simplified. This becomes x plus n over 2 squared is equal to x squared, this guy, plus nx, or xn, same thing, so nx, plus n over 2 squared, right? This guy, correct? And who's this guy? Isn't it the green piece we started with? That's the green piece, correct? That's the green piece. So what does it mean? The green piece then is equal to, so that is to say, the green piece, x squared plus nx, is equal to, think about this as one block. Solve for this. What do? You subtract by this guy, right? You subtract by whatever this guy is, you subtract it to the other side. So you get the green guy, which is x squared plus nx, is equal to this piece minus this guy, right? So you get x plus n over 2 squared minus n over 2 squared. Makes sense? So one more time. I solve for this block. Think about this as one block. If you solve for this block, what do? You're gonna keep this and you're gonna subtract by this guy. So you're gonna get this guy minus this guy. That's exactly what I wrote here. Okay? And now let's pay attention to this last formula that we just obtained. Well, what does it say? It says that if you would like to rewrite x squared plus nx as a perfect square, as something squared, you just have to keep the x and add to it half of the coefficient of x. It used to be n, now here inside is half, right? And then that part is gonna be a perfect square, and subtract the square of the coefficient of x divided by 2. Okay, so subtract from that amount the square of the coefficient of x over 2. Okay, so we get this one, right? So we get this formula. So I'm gonna employ this in the next problem. Let's take number 18. This is still on the same page. Let's take number 18. The function is q of x equals 2x squared minus 4x minus 3. Okay, so that's number 18 now. So still on the same page, that's page 249. And that's number 18 as we said. Okay, so we have q of x, in this case q of x is equal to 2x squared minus 4x minus 3, right? Okay. All right, so what's the question? The question, we have many questions. Part A, write the function in vertex form. So we're gonna write this in vertex form. What's vertex form again? Let's go back to that page. This is vertex form, correct? So we have it written in this fashion. We're gonna transition to this fashion, to the vertex form, and this is by completing the square, right? So that's what I'm gonna do now. And we know how to complete the square based on the discussion we just had. Okay. All right. So I'm gonna label this property something. How about we call it star? So this, I'm calling this whole thing star. So I'm gonna refer to it shortly. So we're gonna transition from this writing to the vertex form. Let's set the stage for star to kick in. So I would like the coefficient of x squared to be 1, right? And it's 2. So what I'm gonna do is I'm gonna factor out a 2 from here so that it becomes x squared, right? And I'm gonna also factor it with this term. So I'm gonna factor the 2 from the first and the second term, because those two terms algebraically they look like this, right? Up to understanding what n is. So one more time, I'm focusing on this part, but I would like the coefficient of x squared to be 1 so that star can be applied. And to do so, I'm factoring out a 2 so I can make this guy a 1. And let's discover what n becomes. So we obtain, if you factor out a 2, you're dividing this guy by 2, you get a 1. You're dividing this guy by 2, you get a 2, right? So you can, distribute back the multiplication over subtraction, check your work backwards, right? If you're more comfortable this way. 2x squared minus 2 times 2, so 4x, right? So you get back to this, minus 3. Okay? All right. And we have this property star. Now I'm gonna complete the square of this guy. I'm gonna complete the square of this guy. And I know how. I'm gonna invoke star, but I need to understand who n is. I'm gonna understand who n is. Think about it for a second. Who's n? Well, n should be, I should have a plus, right? So n should be, if you want a plus here, you should absorb the minus with the 2. So n should be minus 2, correct? So n should be minus 2. So I'm gonna apply star when n is minus 2. So this is equal to, and here I'm using star with n to be equal to minus 2, right? To minus 2. Okay? And I'm just talking about this part. I'm gonna turn it to green so you can contrast it with that. Okay? Alright, so let's focus just on the green part. This is what star handles. It handles this part. So 2 times minus 3 remains outside. Let's take care of the green guy. The green guy is, keep in mind, n is minus 2, right? I'm gonna rewrite this whole thing with my current n, which is minus 2, because this formula holds for any n, right? This holds for any n. We discussed it for any n. There was no constraints on n. So this worked for any n. And so I'm gonna apply it when n is equal to -2. And let's see what we obtain. So we're gonna get, rewrite this with n equals -2. So we get x plus n is -2, right? So -2 divided by 2 squared minus the -2 over 2 squared. I'm writing all the details so you get to see. And let me actually pay even closer attention to the n. N is that guy, right? It's this guy and this guy. So this guy and this guy in the formula. So I'm rewriting this piece, x squared plus nx, this piece, like this when n is not minus 2. I get exactly this, right? I get exactly this. Okay. And now, what do we get? This is 2. I'm still talking about the blue 2. This sits outside. How about the green one now? The green one is equal to x. Negative 2 divided by 2 is negative 1. So plus the negative 1 becomes negative 1, right? Squared minus, how about this? Minus 2 over 2, we talked about that. How much is this? This is negative 1. And if you square negative 1 times itself, it's 1. This minus was already outside, right? Okay. And then I'm gonna keep writing in the blue. So this guy is this piece. And I hope you see that this is a perfect square here, right? Okay. And this is equal to what? I'm distributing now the multiplication with respect to subtraction. So 2 is gonna be multiplied with this, right? And what's 2 times this? It's 2 times the quantity x minus 1 squared, right? And 2 is gonna also be multiplied with the negative 1, right? So 2 times negative 1 is how much? 2 times negative 1 is negative 2, right? And then with the minus 3 outside. Make sense? Okay. And now this is equal to what? This is equal to 2 times the x minus 1 squared. What's minus 2 minus 3? That's minus 5. This is a vertex form. It looks like, remember, vertex form means it looks like it should be written as a times x minus h squared plus k. Remember this thingy here? So this is of the same format then, right? A times x minus h squared plus k. H is 1 and k is negative 5, right? Okay, so that's how we transitioned. What was the key idea? Is to complete the square. And how do we complete the square? I used the property star that I just developed right above that. Okay. All right, so this completes part A then. This completes part A of this problem. So this is done. Correct? Part B, identify the vertex. Okay, so now we're kinda back to the other two problems that we started with in this section. So this is Q of X. This is Q of X. It was given to us as this, right? It was given to us as this, but we rewrote it as this, and this is vertex form. So now everything is gonna jump out. What's the vertex? Based on the property, what's the vertex? So part B, let me try the other one. So part B, the vertex is, it's h comma k, right? It's h comma k. Let's understand what h is. In this case, h is 1 because the formula is a times x minus h plus k, right? So h should be 1 and k should be negative 5, correct? So h is 1 and k is equal to negative 5. So who's the vertex then? It's 1 comma negative 5. Agree with this? Moving on to part C. Determine the X-Intercepts. So we're back to kind of the same questions as above, right? The only difference is is the first question is just a transition from such a form to a vertex form. Part C, determine the X-Intercepts. Determine the X-Intercepts. So part C, we're gonna determine the X-Intercepts. So let me highlight two ways. One way is to do exactly like we did in problems 8 and 10 above. which means set this guy to equal 0, or equivalently, you can set this guy to equal 0, because they are the same guy, either this guy or this guy. They are the same. They're both q, right? So they're both q. Either you set this to be 0 or that to be 0. In problems 8 and 10, we set this to equal 0, right? If you set this to equal 0, you gotta use quadratic formula that you learned in an earlier course. Okay, so you make the call. You wanna use this one or you wanna use that one to equal 0. They're the same, so you make the call. Let's stick with the same approaches that we had, or the same approach that we used in 8 and 10. So I'm gonna have q of x equals 0. That's equivalent to saying 2 times x minus 1 squared minus 5 is equal to 0, right? Q of x equals 0. So I'm looking for x so that q of x is 0. This is how I find the x-intercepts. And for this one, that's equivalent by adding 5 to both sides. 2 times x minus 1 squared equal 5, right? Is equal 5 by adding 5 to both sides. And next, I'm gonna divide by 2. I'm gonna divide by 2, and I obtain x minus 1 squared is equal to 5 over 2 if you divide by 2. Now back to this property that if b is non-negative and a squared is equal to b, that's the same thing as a is plus or minus square root of b, right? So back to this property at this stage, and what does it give in this context? So the a is x minus 1. Let's highlight that. The a is x minus 1, and the b is 5 over 2, right? That's the b. And certainly b is non-negative, right? So what do we obtain? We obtain that a is plus or minus square root of b. So a is equal either the minus square root of b, which is 5 over 2, or the a is plus the square root of b, which is 5 over 2, right? So either this or that. Okay, and what does it mean? What does it mean for x? If you add 1, you get 1 minus, by the way, square root of 5 over 2 is the same as square root of 5 divided by square root of 2, right? So square root of a quotient, square root of a fraction, is the fraction of the square roots. Or, same thing, I'm going to add 1. So I get this, right? Okay? Alright. So these are the x coordinates of the x-intercept. So I'm going to have two x-intercept. 1 minus square root of 5 over square root of 2. I'm going to have another one, which is 1 plus square root of 5 over square root of 2. Okay? So, as I told you, you can either use this and set it to equal 0 and solve it using quadratic formula, or you can set this to equal 0, and this is what I did. Obviously, the answers should be the same. The answers should be the same. I strongly encourage you actually to go and find the same answers that we just found using quadratic formula. So you start here, you set this to equal 0, and you use quadratic formula, and you solve. You find the two x's. They should be this guy and this guy. You may find them written differently, and let me highlight how. You may find them, the other one you're gonna find this being rationalized, meaning the square root downstairs is not gonna be there. So you can rationalize the denominator. You don't need to do this step, but just in case you do the other method, just to let you know that the answers are the same actually. This is the same thing as square root of 5 over square root of 2 times square root of 2 over square root of 2, right? Why I'm doing this? To rationalize the denominator. This is a 1. So this guy is a 1, right? Okay, so I'm multiplying technically this guy by 1, so I'm not doing anything wrong. I'm remaining, this value remains the same. And this is 1 minus square root of 5 times square root of 2. If you multiply these numerators, this is square root of 10, right? Divided by square root of 2 times square root of 2 is simply 2, right? Square root of 2 times square root of 2 is 2. And if you take the same denominator now, the same denominator, which is 2, so you're going to multiply 1 by 2, so you're going to get 2 minus square root of 10 divided by 2. Agree with me? So you take the same denominator. What's the same denominator between 1 and 2? It's 2, correct? So you multiply by 2 downstairs, you multiply by 2 upstairs, you get 2 minus square root of 10 upstairs, and over that common denominator, which is 2. Okay, so you get this. And for the other one, by the other one I mean this guy, it's very similar to this. Instead of minus, I'm gonna just change it to plus, right? It's the same. So this, what I've done here is just rewriting this guy. I'm gonna rewrite that guy, but it's the same process. Instead of minus, I'm gonna have plus. So instead of this minus, I'm gonna have a plus. So x is gonna equal to 2 plus square root of 10 over 2. Okay, so if you use quadratic formula, so if you start from here and you set to equal 0 and you use quadratic formula, what you're gonna find that the roots are actually this guy and this guy. This is what the formula is gonna tell you. And what I'm saying is, since we started from this instead and we set it to equal 0 and solved it in a traditional way, we found those two answers, this one and that one. My point of all this discussion right there is that what someone finds in the quadratic formula and what we found here are the same. They are the same. So this remains the same as this, and that guy remains the same as this. So we didn't find two different things. Okay, all right. So, but for us, this is a great answer. You don't have to write it in a different way. You don't have to transition to this if you get to this point. Okay? All right. Okay, so what are the X-intercepts then? So thus, the X-intercepts. So the X-intercepts are either you use those x's or the ones I had. Just to make the point, I'm gonna copy those. So 1 minus square root 5 over square root of 2 comma 0, and this guy here, right, which is the 1 plus square root of 5 over square root of 2 comma 0. These are the X-intercepts. And based on the discussion we just had, don't forget that this part is the same as 2 minus square root of 10 divided by 2, and this guy is 2 plus square root of 10 divided by 2. Okay, we made the explanation right above. Again, the blue answer is correct and the pink answer is correct. You get to choose which one you want to present your answer as. Okay, very good. So we've done part C. Part D, determine the Y-intercept. So determine the Y-intercept, that's part D. Let's go back to blue. So the Y-intercept is gonna be 0 comma q of 0, and the question becomes, what's q of 0? Right, so the question becomes, what's that guy? Well, what's q of x? I mean, this is q of x and this is q of x. Either this or that. They're the same. They're not two different things. They are exactly the same but written differently. So q of 0, evaluate q at 0 either using this recipe or that recipe. I'm gonna use this recipe this time. Q of 0, I'm gonna plug in 0 for x, right? So this vanishes, the only survivor is minus 3. Okay, so what's Q of 0? Is minus 3. And as such, what's that point? What's that y-intercept? Is the point 0 comma minus 3, correct? Okay, part E. Part E, sketch the function. Sketch the function this time. Alright. So we've sketched the functions, such functions before. Let's pay attention to this formula. The standard or vertex form of the quadratic function. So we have the vertex at 1 comma negative 5, right? So let's start putting information together. So we have the xy plane. So we have the vertex, which is 1 comma negative 5. Where is that? 1 comma negative 5. So somewhere, let's say here, right? So this is the point 1 comma negative 5. The x coordinate is 1, the y coordinate is negative 5. Okay. I know that the function, the parabola is going to open upward because the a is positive, right? This is the a is positive. So it's going to open upward. And then it's going to cross the y-axis somewhere. Where is that point? It's 0 comma negative 3, correct? 0 comma negative 3, we found it. So it's going to cross at negative 3. So let's say here. Correct? Okay. I didn't hit it, so I'm going to erase it. So let's say here. That's the y-intercept, 0 comma negative 3. And those guys are the x-intercepts, right? Which we found in one of the parts of this problem. Let's take this figure and plot it here. So let's be clear about the x-intercepts. One of them is this, the other is that, right? Certainly this guy is the smaller one. It's 1 minus. So certainly this guy is this piece, this bullet. So this guy is 1 minus square root of 5 over square root of 2 comma 0, right? And this guy is 1 plus square root of 5 over square root of 2 comma 0. Okay? So these are the x-intercepts. Okay. Part F. Determine the axis of symmetry. So it's the same sequence of questions as 8 and 10. Determine the axis of symmetry, and the axis of symmetry based on the property, it's that line x equals h, right? And h happens to be 1 here. We talked about that. So h is equal to 1, right? Where is it? It's right there. Correct? Okay. So the line then, this is part F. So the line of symmetry, or the axis of symmetry, is the vertical line x equals 1, x equals h. Alright, part G. Part G is determine the minimum, just a second, my bad. So determine the minimum or maximum value of the function. So minimum or maximum. How about this function here? Because it's opening upward, there's no largest point because it blows up. There's no largest height it's gonna reach, right? It keeps going up. But there is a smallest value, a minimum that it's gonna attain, and that minimum is attained at x equals 1, and that value is negative 5, right? It's q of 1, which is negative 5. Okay? So the minimum is attained at x equals 1, and that value and that minimum value is the function acting at this 1, this h, which happens to be k, and k is -5, right? Because that guy is q of 1, right? Because this point is on the graph of q, so the second coordinate is the image of the first under the function. Okay? So the lowest it reaches is -5. Okay, and lastly, like before, write the domain or range in interval notation. So write the domain and range in interval notation. That's h. The domain of the function, the domain of any quadratic function is all real numbers. So the domain of q, is all real numbers, and the range of q is, well, the function outputs all real numbers that are from this lowest point onward, right? From this lowest point, which is the minimum it attains, which is -5 onward. So it attains all points that are from -5 onward, right? Okay. So in interval notation, let's say -5 all the way to +infinity. Okay. Let's do one more problem where we have to write a quadratic function in vertex form. So in other words, to complete the square, right? And let's do number 22. So we have k of x is equal to 3x squared minus 8x. I'm gonna only do part A because for the rest we've done it 3 times by now, right? So I'm gonna just do part A for number 22. So we have k of x equals 3x squared minus 8x. And I wanna rewrite this quadratic function in standard form. So what was the key idea? It was to complete the square, which means we need to use the star equation that we developed before, correct? So this one. So let me put it here, and I'm gonna appeal to it just shortly. So we have 3x squared minus 8x. In order to use star, I need the coefficient, as we said before, for x squared to be 1. As of now, it's 3, so I need to factor out this 3. And I'm going to obtain x squared minus, so I'm dividing this one by 3, I get 1. And I'm dividing this one by 3, so I get 8/3 x. And I didn't have a constant part, so I'm not going to have anything outside like I used to in the previous problem, right? Let me take you back there. I remember here I had this guy, so I put it, I carried it over. In my current context, I don't have such a thing, right? So I have a 0 as a constant, as the constant term. Okay, so now this is the green part, right? This becomes the green part. Which green I'm talking about? The one in the star equation, right? Okay. So now we're gonna use star. So we're gonna use star. And let's be clear, with n in the star equation to be what? So who's the n here? If you make direct comparison, who's the n? X squared is this, x is that. The n should be -8/3, right? So the n is -8/3. Okay? Alright. So I'm gonna copy now the right-hand side of star, because the green guy is this right-hand side of star, with the n to be -8/3, right? Okay, so I'm gonna keep that 3 outside, the blue one, times the green guy. And the green guy, now I'm gonna look at the recipe of star. It's gonna be x plus n. How much is n? -8/3, right? -8/3 divided by 2. squared minus the square again of my n over 2, and n over 2 was minus 8 over 3 divided by 2, right? Okay. So I use star now. I'm gonna erase it. I don't need it anymore. But one more time. So n is minus 8 over 3. So I'm using star with n equals minus 8 over 3, and we get this, right? So that's the green part that's equal to this green equation, green expression. Okay. All right. Let's erase everything. Okay, very good. So we get that this is equal to 3 times let's understand what this guy is. Okay, what's this guy? What's minus 8 over 3 divided by 2? This fraction bar is the same thing as division, right? The numerator is minus 8 over 3, and the division bar is division operation divided by 2. And what is that? This is minus 8 over 3 times, if you want to divide by 2, it's the same as multiplying, as it's the reciprocal of this, right? The reciprocal of 2 is half. Okay, what's minus 8 divided by 3 times 1 over 2? That's minus 8 divided by 3 times 2, right? 3 times 2. And if you simplify by 2 now, you get minus 4 divided by 3. Right? If you simplify by 2, you get minus 4 over 3. So this guy is minus 4 over 3 then. Okay? Alright, let's copy. So x plus this guy, which is minus 4 over 3. So with this plus, it becomes minus, right? There was a plus here. With this minus, it becomes minus. So minus 4 over 3 squared minus, don't forget, that's the same guy. That guy is the same, right? So this guy is the same. It's this guy too, correct? Okay. So that's still the square of this guy, which is minus 4 over 3. Okay. Okay, so this is then equal to 3 times this guy, which is x minus 4 over 3 squared, minus, what's the square of minus 4 over 3? This is the same thing as saying minus 4 over 3 times itself. So negative 4 times itself is 16, and 3 times itself is 9. So we get this. Okay? Alright, now I'm going to distribute the multiplication over subtraction. So 3 is going to be multiplied by this guy. What am I going to get? I'm going to get 3 times x minus 4 over 3. Remember, my I is on the vertex form. And then 3 is going to be multiplied by the 16 over 9 with the minus sign. And what is that? That's minus 3 times 16 over 9, right? Clearly, I can simplify here by 3. And if you simplify by 3, we obtain what? We obtain 16 divided by 3, right? Because 3 divided by 9 is 1/3, so we get 16 times 1/3, which is 16 over 3. So this is the vertex form of this quadratic equation, function, right? This one. So this one and that one, they're both k of x. They're both k of x. Okay? So I'm going to ask you to complete the rest. So for parts B through H, so please complete on your own. They're left as an exercise. This function here, k, is gonna have, because a is positive, it's gonna be, it's gonna open upward, right? Because a is positive, and hence it's gonna have a lowest value, a minimum value, correct? If A is negative, then it's gonna open downward and it's gonna have a largest value, correct? So what if instead, so instead of starting from a concrete recipe for the function like 3x squared minus 8x, instead of having concrete numbers, what if I start from a function that's, or a quadratic function that's abstract, that looks like ax squared plus bx plus c? Okay, so we know we can transition by completing the square like we've done here, but we've done it for concrete ABC, right? A in our context was 3, B was negative 8, and C was 0 in this previous problem. So, but for sure we can transition to something like this, right? Correct? Which is in vertex form. This is what the property says. And we've done it concrete. We've done it for examples. Now the question is, in abstract context, what is H in relation to A, B, and C? What's H in terms of A, B, and C, right? So let's try to tackle this question. So the question again, I have an abstract quadratic function that looks like ax squared plus bx plus c. I don't know what A is, I don't know what B is, what C is. The only thing I know is that they are real numbers and A is not 0. And the idea is to find H where the maximum or minimum is attained, right? At H always the minimum or maximum is attained depending on A, right? H is gonna become the function is gonna attain its largest element if A is negative, and at H is gonna attain its lowest value if A is positive, right? So this was the idea, but the idea is at H this is gonna happen. So how do we find the recipe of H for abstract A, B, and C? Okay, so that's the next question. Okay, so let's move on to that question. So we have an abstract context, f of x equals ax squared plus bx plus c. And what I want to do is I want to transition to the vertex form or standard form and find concretely what H is in terms of A, B, and C. Okay, so what was the key idea? The key idea was to use to complete the square, which means we need to appeal to the star equation, right? So the star equation, that guy. So I'm gonna appeal to this. Let me just make it smaller. Okay, so let's use it, but before we use it, we need to make the coefficient of the x squared 1. It's a, so a may not be 1. So let's factor a out and get x squared plus, if you factor a out, you're dividing this guy by a, you're dividing this guy by a. If you divide a by a, you get a 1, the desired one. And if you divide b by a, you get b over a, right? X plus c. So who's the green guy here? That's the green guy, right? That's that green guy. Okay? Now the question is, who's n? Who's n? Well, so n should be b over a, correct? N is simply b over a. Okay, so I'm gonna use then star. I'm gonna use star with n to be, as we said, with n to be b over a, right? This doesn't look like star to me, so let's do it again. Okay, so we're gonna use star with n to be b over a. Let's do that. Let me make this bigger. Maybe you cannot see it on the screen, the video. Let's do that. So what do we have? We get a, that's the a, times, let's keep the green in green, plus c, right? So let's keep the green in green. X squared plus b over ax, that's gonna be this part with the n to be b over a. Let's copy. So x plus the n is b over a, right? So b over a over 2, so that's b over 2a, right? Squared minus the n, which is b over a, so b over a over 2, and that's b over 2a squared, right? Okay, so I use star. I don't need it anymore. I'm gonna just erase it. Okay, and then this is equal to, again, I would like to transition as usual to the vertex form and discover what h is in terms of a, b, and c. So let's keep going. A times that green piece, which is a perfect square, so I'm gonna keep it because that's the piece that's needed. Actually, you can already see what h is, right? Let's pretend we didn't see it. Let's keep going. Minus b squared over 4a. This is b squared over 4a squared, right? b over 2a squared. This is b squared over 2a over 2a times 2a. So 2a times 2a is 4a squared. Plus the c, right? Plus the c. Okay. All right. Now, as usual, the a is gonna talk to this entity, and it's gonna yield a times that guy, right? So a times that guy minus, still a is gonna talk to this quotient, so it's gonna we're gonna get a times b squared over 4a squared. So ab squared over 4a squared, correct? Plus the c outside, plus the c. Okay? I forgot the square here. Correct. So this is then equal to a times x plus b over 2a squared. I can cancel that common a, right? Correct? So maybe I should make the point, when I factored a outside, I'm writing division by a, and don't forget a is supposed not to be 0 for this to be considered quadratic function, right? So I'm allowed to divide by a. That's my point. So since a is not 0, I should say here, since a is not 0, I'm allowed to divide by a, correct? Okay. All right, so now I'm simplifying by this common factor a, and I get minus b squared over 4 plus c, correct? 4a, I forgot the a. So one more time, b squared over 4a plus c. Okay? So that's the function then. That's the function written. That's the function. Which function I'm talking about? I'm talking about this abstract function ax squared plus bx plus c. But now it's written in standard form, right? So who's h? So thus h is minus b over 2a, right? Because the general formula was what? It was this, right? This one. So let's copy it and take it with us to the page. So this is the general form, right? This is the general form. Now compare the two. Let me blow it up so we can compare it clearly. So let's compare now the two. So who's h? So who's h? With a minus sign, don't forget. So h is gonna be, because I have plus sign here, h is gonna be the opposite of this guy, correct? So h is then the opposite of b over 2a. And who's k? K is this guy, right? So k is minus b squared over 4a plus c. The recipe of k in general is ugly, but the recipe of h is clean enough. So it's the opposite of b divided by twice a. So this is what h is, right? So I don't need this anymore. This is what h is. So all the time, whenever we, so in all the problems we dealt with, the h that we obtained, especially those last two, the h that we obtained, which was 4 over 3, right, in this case, the h that we got was minus b over 2a. Let's check it. We got here 4 over 3. And is the 4 over 3 minus b over 2a? So minus b over 2a, is it that guy? So this is the b and this is the a, right? What's negative b over 2a? It becomes negative the negative 8, because b itself is negative 8, divided by twice a, and how much is a? Is 3, right? So isn't that 4 over 3? Isn't that 4 over 3? So that's the h. That's the h that we found at the time. Correct? It was here, 4 over 3. It's right there. So my point is, what this little exercise is trying to illustrate is, in general, no matter what a, b, c are, as long as a is not 0, the h is always minus b over 2a. Correct? So we have now a concrete recipe for the first coordinate of the vertex in terms of a and b. The c is not gonna go as an ingredient, as an active ingredient in the recipe of h. It's part of the k, the y coordinate of the vertex. Okay? I hope this makes sense. And since at h the function attains the largest, or either the largest value or its lowest value, so that number is, the image of that number is going to be either the largest or the lowest value, depending on what little a is, right? If little a is negative, then the function is going to attain its largest value at h, so f of negative b over 2a is going to be the largest value, and if a is actually positive, then f of that guy is going to be the lowest value that the function takes. Correct? So that's the next property, the one I just talked about. So let's read it. The maximum or minimum value of a quadratic function f of x is equal ax squared plus bx plus c occurs at this point, minus b over 2a. It's the same point that we just talked about, right? It's the h, minus b over 2a. Correct? So that extremum, either maximum or minimum, occurs at this point. Now it's a minimum if a is positive, so f of that is going to be the smallest value that the function takes, and if a is negative, then f of that is going to be the largest value that the function takes. Okay? So in addition to this, we, as we discussed above, so minus b over 2a is the h, and this guy, which is f of h, right? F of h is the k, which is the y-coordinate of the vertex. So this is the x-coordinate of the vertex, which is minus b over 2a, and this guy is the y-coordinate of the vertex. Don't forget, h here is minus b over 2a, right? This is the case all the time for any quadratic function. Okay, so let's actually record it here. So in addition, the vertex of the quadratic function f of x equals ax squared, so ax squared plus bx plus c, is given by this formula that we just discovered, is given by the h is minus b over 2a, and the k, which is f of that, it's the other component, which is minus b squared over 4a plus c, but as I said, I mean, it's ugly to memorize, so I'm gonna just keep it as f of h. Correct? H is easy to recall. Okay, so this formula is called the vertex formula. So this is called the vertex formula. Let's do an example to this point. Let's go to the same page and let's do number 26. So find the vertex of the parabola by applying the vertex formula. So I have g of x. Let me copy this. So I have g of x to be 4x squared minus 64x plus 107. Okay, so what are we gonna do? We're gonna find the vertex using the vertex formula that we just talked about over here. Okay, all right, so let's do it. The vertex is given by minus b over 2a. That's the h. That's the x coordinate of the vertex. Okay, let's highlight what a, what b, what c are. I only need a and b. So a is 4, b is negative 64, right? Because in the abstract one I had a plus. So if you want to turn this into a plus, you have to absorb the minus to the 64. So it becomes negative 64. And the c is 107, right? It's the constant part, the c. Okay, so minus b. So minus b becomes minus the minus 64 divided by 2 times a. And a is 4, right? So it becomes like this. So this is 64 divided by 8, which is simply 8, right? So h is simply 8. Okay? All right, and then the k, the y-coordinate of the vertex, right? The y-coordinate of the vertex is the image of h, under the function. The name of the function is g. The image of h is 8, under the function g. So just plug in 8 here and figure out what this k is. So it's 4 times, I'm plugging in 8 for x, right? So it's gonna be 4 times 8 squared minus 64 times 8 plus 107. Okay, and you do the algebra here, and you obtain minus 149. Okay, so just do the algebra. The answer is minus 149. This is the same thing as if you were to go here, to go in this one, and replace the b by the appropriate b, and the a as well, and the c. So if you replace the a by how much was a? By 4, and the b by negative 64, and the c by 107, if you replace those 3 numbers in this recipe, you're gonna get exactly what we just found, which is f of that h, right? We're gonna get exactly what we just found, which is negative 149. Try it. Okay? All right, let's do another one. How about we do 30? Same question. Let's do 30 now. So we need to find, okay, the name of the function here is h, but it's different than the h we're talking about, right? So this h is the x-coordinate of the vertex, right? So the vertex is going to be given by negative b over 2a and f of negative b over 2a, correct? Let's not label them as h and k anymore. So negative b over 2a and f of that. Let's find what negative b over 2a is. So the ingredients are a and b. Let's find them. What's a and b here? A is 2 and b is 0, right? There's no coefficient for a squared. By the way, a is the variable, so it's playing the role as the input. Okay, so 2 is the a, b is 0. Why b is 0? Because the only way that the BA to vanish, not to show up, is that if b is 0, right? The b is being 0 is gonna allow this term to vanish, and hence you don't see it. And the c is 14, right? And the c is 14 in this case. Okay, so what do we obtain? We obtain that negative b over 2a is, so negative b over 2a is 0. Negative 0 divided by 2 times 2, okay? So that's 0, right? So this guy is 0. And f of negative b over 2a is f of 0, because we know that this guy is 0, is f of 0. And how much is f of 0? If you replace a by 0, you get 14. Correct? So who's the vertex then? The vertex is 0, 14. And the explanation is right in this color green. Okay? So the explanation is in this bubble. Green. The green bubble. Make sense? So the vertex is 0, 14 because of this explanation. Let's now do an exercise. So let's write down an exercise, not from the book. Let's say the following. Evaluate the maximum or the minimum value of the following quadratic function. F of x equals minus 2x squared plus 4x minus 5. So we just need to evaluate the maximum or minimum value of this quadratic function. Well, first of all, does this function attain, does it have a largest value or a lowest value? Does it have a maximum or minimum? Well, because a, the coefficient a is negative, right? This is the a guy, it's negative, then the function is gonna open downward, right? And as such, it's gonna have a largest element, correct? So it's gonna have a maximum value. Since a is negative, let me explain that. So since a is equal to -2, which is negative, the function doesn't have a smallest value, or a minimum, but it does have a largest value. So the function has a maximum value, because that guy is negative, right? Which is by the last property, by the previous property. What do I mean by previous property? I mean this guy, this property here, this thing, correct? According to this, I know that the largest value, because a is negative, the largest value is going to be attained at f of that number minus b over 2a, which is the first coordinate of the vertex, as we just discussed below, right? So f of that is going to be the maximum value I'm looking for. So which is by the property above. So by the property above, actually I'm gonna say which by the property above is given by f of negative, not f, yeah, f, the name is f, minus b over 2a, right? Correct? So who's a, who's b here? We know what a is, it's -2. And who's b? b is 4, right? b is 4, that's b. So that's going to be f of negative, the b, which we just said is 4, divided by twice a, so twice the -2. Correct? Twice the -2. So minus b over 2a, b is 4, a is -2, we get this. And what is that? This is f of, what's 4 divided by 4, -4? That's -4 downstairs. 2 times -2 is -4. 4 times -4 divided by -4 is -1. With that minus, it becomes a 1, right? So f of 1. The h is 1 then. The h is 1. And at this point, I'm gonna find the largest value that the function reaches, and this is nothing but the y-coordinate of the vertex, correct? The y-coordinate of the vertex, because the function looks like this. So that tip, that peak, has 1 f of 1, that vertex, right? And f of 1 is the y coordinate of that vertex. Okay. Very good. So what's f of 1 then? F of 1, replace x by 1. And what do we obtain? Minus 2 times 1, that's minus 2, plus 4. Minus 2 plus 4 is plus 2, minus 5 is minus 3, correct? So that's minus 3. Let's actually complete. Let's write everything. So I'm going to replace x by 1 to find f of 1. And as such, I get minus 2 times 1 squared plus 4 times 1 minus 5. And as we said, this is minus 3, right? So minus 2 plus 4 is plus 2, minus 5 is minus 3. So that's this guy, minus 3, is the largest value that the function takes. Okay, so the function, which is going to look like this, that point 1 comma negative 3, this is where the x-axis is, correct? And as it happens, the function doesn't cross the x-axis. It's not going to have x-intercept. You can try it. It's not going to have x-intercept, which means if you set this to equal 0, there's no solution here. Okay? The quadratic formula is not going to work because the discriminant b squared minus 4ac is going to be negative in this case. Anyway, so the vertex is going to be at 1 comma negative 3, and that negative 3, this height is the highest the function reaches. All the other values it takes are lower than minus 3, right? Okay. Let's now see how all the theory that we've learned in this section, how it plays out in application. Let's do the following problem, 52. Okay, so let's copy that. This is an optimization problem. Optimization has to do with minimizing or maximizing a certain function. So the question is as follows. The difference of two numbers is 30. Okay, so there are two numbers, their difference is 30. And there are many numbers there are many two numbers so that you take their difference to be 30, right? But we don't want all of them. What we want is we want those guys, those two numbers, so that the product is minimized. So one more time. I'm gonna find two numbers so that their difference is 30, but their product is minimum. The smallest product that you can get if you take the product of two numbers so that their difference is 30. This is what the question is about, correct? Okay, so let's give ourselves a context. So let x and y be two numbers so that such that their difference is 30, right? So if x minus y is 30, that's the same thing as saying that y is x minus 30, right? Correct? If you subtract by y, if you add y to both sides and you subtract by 30, that's the same thing as saying that y is x minus 30. Okay? All right. So what we want is we want to minimize their product. So let's create the product function and try to minimize it. So introduce the product function and let's label it as let's say P for product. So the product function P defined as follows. So it's gonna be, so the product function P is gonna be the product between x and y, right? Those two numbers so that their difference is 30. Okay? So the function P is x times y. it looks like this is a function in two variables, x and y. No, this is a function in one variable because you have a relationship between x and y, this or that, right? So you have a relationship. You can rewrite y in terms of x, correct? So it becomes, if you rewrite this guy y in terms of x, so meaning replace it by this piece, it becomes a function in one variable, okay? So that is to say p, the function p is x times the y, and we just made the case that y is x minus 30, right? So this becomes a function in one variable, and that variable is x, so let's write it as p of x. P of x, correct? Okay. So what do we want? We want to minimize this function p, right? We want to minimize this function p. We want to find for which x this function p attains its minimum. All right. Well, this function p, if you pay attention to it, this is quadratic, right? This is quadratic. P of x is simply x squared minus 30x, and this is clearly quadratic. And does this function have a minimum? Yeah, because the a is 1, which is positive, right? That's the a. That's the a. It's positive, correct? And if a is positive, the function is going to open up and it's going to have a minimum, right? And that minimum is going to be attained somewhere. And that's what I'm trying to find. That's what I'm trying to find. I'm trying to find the appropriate x where this is going to occur, correct? Let's call it x sub min, because it's the one I'm looking for. It's the x that minimizes the function. Okay, so how do we get our hands on this x? Well, we know what the recipe of x is, right? It's the x coordinate of the vertex. It's minus b over 2a by the vertex formula that we just talked about just a few minutes earlier, right? So by the vertex formula, we know that, so we have that x min, this guy, the x coordinate of the vertex, that's what x min is. X min is equal to minus b over 2a, right? Correct? This is what the vertex formula tells us. The minimum is reached at minus b over 2a. Okay? And what's minus b over 2a? Well, who's b here? b is negative 30, right? So that's going to be negative the negative 30 over twice a, and a is 1. Correct? b is negative 30, right? Because in general you have ax squared plus bx plus c. b is the coefficient of x as long as you have a plus. The coefficient of x is 30, but you have a minus here. So in order to make it a plus, you have to absorb the minus, right? Like this. Okay, so b is how much? b is negative 30. This is why you have this quotient. Okay, and how much is that? Negative the negative 30 is 30. 30 divided by 2 is 15. Alright, so now I know where this function, this product function p, is attaining its minimum. It's attaining its minimum at 15 when the x coordinate of the vertex is 15, right? So when x is 15, we have the vertex. Alright, so we know what one of the two numbers then are. Remember, I'm after two numbers so that their difference is 30, and I want their product to be the lowest it can be. Well, one of the numbers is 15. So if one of them is 15, how can you discover the other? If x is 15, how can you discover the other? Well, if this guy is 15, 15 minus 30 is going to be the y. Correct? So let's call the y to be y min as well. So furthermore, so y min, the other number, y min, is going to be x minimum minus 30, right? I'm following this recipe. So because their difference is 30, y is going to be x minus 30. If you find x, then the other one is going to be that number minus 30. We found this guy to be 15. So 15 minus 30 is going to be the lowest, or it's going to be the y that corresponds to the minimum product. And what's that? What's that guy? So if x min is 15, this becomes 15 minus 30, and this is clearly minus 15. Correct? So in summary, the two numbers are this 15 and negative 30. This is the conclusion. So conclusion. So as a consequence, the two numbers whose difference is 30 and have the smallest product are 15 and negative 15, right? Their product is the lowest two numbers whose difference is 30 can get to. Okay, so 15 times negative 15 is the smallest product that two numbers whose difference is 13 can get to. Okay, let's do another optimization problem, and let's do number 56. Let's take it as a snapshot. Let's paste it in the notes. Alright, so what does it say? Let's zoom in to see it better. A rectangular frame of uniform depth for a shadow box is to be made from a 36-inch piece of wood. So you have a rectangular frame whose depth is uniform for a shadow box, okay, is to be made from a 36-inch piece of wood. So from this, okay? So what they have is this frame has one of the sides of length x and the other side of length y. They labeled them. Okay. Part A, write a function to represent the display area in terms of x. So they wanna have this displayed area here. So they wanna have it in terms of just x. So this area is x times y, right? So x times y is the area. Okay, but what do you know about x and y? You know that x plus y plus x plus y, which means the sum of all those sides, should equal 36. Am I correct? Because out of this, they're gonna construct that. So definitely the length of the sides should add up to 36. Am I correct? So I know that x plus y plus another x plus y, so twice x plus y should be 36, right? I'm establishing a relationship between x and y. So hope this is clear. One more time. I know that the sum of all the sides should be 36 because that's the piece of wood that I'm making the frame out of. That is to say that x plus y is 18, right? If you divide both sides by 2, this is multiplication, so you get 18, which means one of them, let's say y, is equal to 18 minus the other, right? 18 minus x. So this is a relationship between y and x. Okay, how about this area? Let's call this area calligraphic A. So how about this area then? So then this function, this area function, which is x times y, right? Which is x times y, is equal to, or is equivalent to, x times the y is 18 minus x, right? So the y is 18 minus x. Now I have a function in one variable. One more time. So the relationship between y and x is as such, and the area, which is x times y, the area of a rectangle, x times y, It seems that it's a function of two variables, but y, don't forget, is a function of x itself. So x times y becomes x times 18 minus x. So that's the area function, and it's in terms of x clearly now, right? It's in terms of x. Okay, so that's then the area. That's part A. You can obviously say that this area is equal to, if you distribute the multiplication over subtraction, you get, what do you get? You get negative x squared plus 18x. Am I correct on this? Let me see. So if you multiply x times 18, you get 18x. If you multiply x times negative x, you get negative x squared. So that's part A. That's part A. Okay. Part B. What dimensions should be used to maximize that area? So they want to maximize the area. This is quadratic. This is quadratic. And the coefficient of x squared is -1, right? Is -1. So this function is going to be upside down. The parabola is going to be upside down. It's going to be concaving downward, right? It's going to open down. So as such, it's going to have a largest value. It's going to have a largest value. The question is for which x and for which y this happens. For which x and for which y this happens. So let's find that x, because now it's a function of x. Let's find that x. Let's call it x max. So the coordinates of these points, the first coordinate is going to be x max. Correct? And the second coordinate is going to be the area that corresponds to this x max. Make sense? So this would be the second coordinate of that vertex. So what's the first coordinate of the vertex? X max, we call it the x coordinate, or the x value that maximizes the a function, the area function. Well, this is given by that property that we talked about, which is also the same as the vertex formula. So minus b over 2a. Correct? So minus b over 2a. Well, who's b here? Who's b and who's a? So we talked about a. A is -1. And b, which is the coefficient of x, is 18. Because I have a plus here, right? So it's 18. Okay. So this is then equal to negative 18. Okay, so technically, if you want, that minus is upstairs, right? This is the same. So negative 18 divided by 2 times a, and a is -1. Correct? And how much is this? This is negative divided by negative, so that's plus. 18 divided by 2 is 9. So the largest x, or sorry, the x that makes the area as large as it can get to is 9. And what's the unit here? It's in inches, right? So it's 9 inches. So to maximize this display area, the x should be 9. Okay? So if the x is 9, how about the y? If the x is 9, how about the y? Right? So we know the relationship between x and y. If you found the x, you can give yourself the y. The x happened to be 9, so the y is, so it follows that the corresponding y, let's call it y max, is equal to 18 minus the x max, right? So what's x max again? It's the x dimension. It's that dimension that maximizes the area. And what's y max? It's this dimension that maximizes the area. Correct? Okay, so what was x max? Was 9. So this becomes 18 minus 9, because this is 9, and 18 minus 9 is 9. Correct? And what this is saying is that the largest, or the rectangle whose area is the largest, is actually a square. This is what we just discovered. Correct? So what we discovered, I'm summarizing it just using plain English. The rectangle, right? The rectangle whose area is the largest it turns out to be a square because the x and the y should be the same. The x and the y should be the same. And this is not, I mean, I'm not sure if you've heard it at least before. This phenomenon is explained at least for when the sum of them is 36. Okay, so now we know what the dimensions are. And the last part, which is the C, what's the maximum area? What's that maximum area? Well, the maximum area is going to be the y-coordinate of the vertex, so ax max, right? So C, the area corresponding to this x max is going to be the largest area that you can get in this display frame, right? In this display area. So what is that? Well, replace x by 9, we get minus 9 squared plus 18 times 9, right? So one more time, the largest area that the function get, or the largest area that that frame can get, is when x is 9, right? So when x is 9, I'm gonna have minus 9 squared plus 18 times the 9. Okay, and how much is this? You can just do it your way. I'm gonna factor out a 9 here. If I factor out a 9, I'm gonna get minus 9 plus plus 18, correct? And this is 9 times 9, which is 81, correct? Again, which is not a surprise because it's x times y at the end of the day, correct? It's x times y. The area is x times y. If you know the x and the y, if you know them, just multiply them together. This is exactly what happened in this little work here. 9 times 9 is 81. And that's the area that's the largest area that you can get in the context. Okay? So let's respect the units. This is in inches. This is in inches. Right? And this is in inches squared, right? Okay. All right. So that completes the current section.